Good morning, everybody, and welcome to openSUSE. Here we're going to have some of the workshops of openSUSE. And we start with the puppet show from our puppet master, Theo Chatzimichos. Good morning, Ali.
Thank you.
For those watching the streaming live, if you would like to ask any questions, please in IRC, in the free node server, in the openSUSE Pavla slash nft Pavla dash openSUSE dash conference. You can ask the Geeko, the openSUSE one bot, and Theo will answer the question.
Okay, thank you. Welcome everybody. For the people from abroad, welcome to Greece. I'm very happy to see you here. I was one of the guys that organized the conference in the last year, and I'm very honored to have it this year in my country. So, in this workshop, we are going to talk about Puppet, pretty new technology, pretty young technology. Anybody in the room ever heard of Puppet? Or Chef? Okay. Okay, don't worry. I'm going to present it. I'm going to give a small talk about it first for about 20 minutes, and then we are going to the actual workshop part, where you can also participate. So, first of all, in order to participate later in the workshop, you need to have it installed in your system. For the openSUSE machines, the command is zypper install puppet. If you are having any other distribution and need any help, just let me know for installing it. And I have also prepared a bunch of examples for a bunch of example code. This is the address where you can find them. And this is how you can unpack them so we can use them later. So, what is Puppet? What is this technology talking about? And why does it exist? What's the problem it tries to solve? Here is the problem. We have a bunch of servers and around 50, 100, maybe thousands. Depends on our infrastructure. We have a bunch of custom scripts that we use to administer the servers in order to automate some operations. We need to touch a lot of config files manually for our web server, for our database, whatever. But the thing is that if we have, for example, a large infrastructure with, let's say, 10 web nodes, we need to duplicate the same work in all of those servers. And if the web nodes are running different operating systems or they have different package names, then things get more complex. The problem gets more serious if we have not only one sysadmin, but we have a group of sysadmins administering the services. Then we have pretty much no automated communication between the people in order to see what changes were done by whom and when, and most of the cases why those changes were done. What was the problem that was trying to be solved in that time? So it's very hard to communicate. It's very even hard to remember what you did after 1 month. Not imagine having to read some others' config files or to have to search some other guy's config files in any server. So it's impossible to see exactly what the other guys did, and it's more impossible to review those changes or even test or provide some quality assurance before pushing those changes to the servers. So the solution for that problem would be a central storage place for all the config files, a central repository where we can put all of our config files and keep them there, instead of having them spread around in a bunch of machines and in a bunch of file systems. We need an easy and secure distribution of the config files along to the servers, So we need a central repository that will just push the changes to the appropriate services and the servers each time. Also, we need to categorize those servers. We need to put some labels there, like our web nodes, our database machines, our, I don't know, version control machines, or our NFS machines. And maybe sometimes we would also need some conditions on the installed configs. For example, for an SSH configuration file, and maybe in one server we want to change the default port from 22 to something else. So it would be very nice to have some conditions there and say if the host name is this one, then change the default port to something else. And we need some version control here. We would really need some help from some version control like Git to have history, to have revisions, to have differences between all those changes. And also we would need to handle all those, apart from the config files, we would also need to handle some other files like custom scripts, users, installation of packages, cronjobs, and of course we would need to have support for different operating systems. So this is the Puppet. This is what Puppet does. This is what it tries to provide. It's a central configuration management system or an IT automation software, and it pretty much supports all of the things that I mentioned in the previous slide. More specifically, it's an open source product. It's written in Ruby. It has its own declarative language, although, which is very similar to Ruby, so even people that have no experience about Ruby but have some experience with any scripting language can find it very easy to write some Puppet manifests. It categorizes the files, its code into modules that contain more, how to say, the modules group up the config files and other operations that we need to do per service usually. In my presentation on Monday, I'm going to give a very extended talk about how to actually put some hierarchy into your Puppet modules in order to have clean code. Puppet, apart from its declarative language and its classes, it has also support to create custom data types in plain Ruby, for those that know some Ruby. But actually, I think it's pretty easy to learn such a language nowadays. And apart from code, it also supports like static files with a file bucket, like text files. And it can also apply some tests to the changes that you make before pushing them to the production servers. So you can actually see if you actually cause any regression to the servers before doing some major change there. And it also has templates that could support conditionals that I mentioned before with the SSH default port. Apart from that, apart from the software, it also has a very strong community. It's one of the major reasons it got very popular in such a short time, actually. The community developed the company developed Puppet dashboard, but the community took it over because the company didn't want to maintain it anymore. And also there is a Puppet Forge, which is a central application store where you can upload your own modules, your own Puppet modules, and you can also reuse somebody else's Puppet modules. So you don't have to start from scratch when you want to write some code about this. It also has IRC, mailing lists, and all of them are very active. I'm participating in a bunch of them. And it also has a bunch of conferences and other events. For example, it's worth mentioning the Puppet Camp, which is an event that is being organized by individual companies in any place in the world. I've participated once in one of them in Nuremberg. And their biggest event is the PuppetConf that is going to be, I think, next month in San Francisco. Apart from the open source version, though, they have also an enterprise version of Puppet. According to the Puppet Labs guys, they usually test the features in the open source version and then push them to the enterprise one, where if you have a company, you can also have the enterprise version for better support from the Puppet Labs company. And as I mentioned already, the company behind Puppet is called Puppet Labs, and it's extending pretty rapidly these days. Here is a graph that shows how Puppet actually takes our code and brings it to the machines in order to have the defined system state. In short, it takes the manifests. Manifests are the files, our code, our Puppet code, that they get compiled. And then it creates a catalog. Catalog is like it's like a version. So it can check if the agent asks for a new version, it checks the catalog numbers to see if there are actually any changes for the specific host that need to be pushed. Then it tries to apply the changes into the agent, and we get to the defined system state. What is really awesome here is that if we write some good manifests, we can bring a machine from any state to our desired state. A completely destroyed machine or a machine that is running a completely different operating system and completely different services. If we write some good manifests, we can bring it to exactly the defined state that we wanted, and even have a clone of another machine in case of clustering. So that was all that I wanted to say about the Puppet. And now we can proceed into writing actually some code and checking the examples that I prepared. So for those that want to participate, again, you need Puppet installed in your system. And before that, I'm going to show you how the agent and the master connect to each other. So in this laptop, it is running both a master and an agent. Is that clear? Should I make the font bigger? Is the font good? Should I make it bigger? Okay. So the Puppet master is running, and this command is showing all the connected agents. The CA means certificate authority, so the communication between the master and the agents gets through SSL. So the master gets all the certificates from the agents, and then we have to manually sign them in order to make them trusted. After the signing process happens, then the master and the agent can communicate to each other normally. The procedure pretty much is that agent asks for a new catalog, for a new version. Master checks in the central repository if there are any actual changes for that agent. Then the agent proceeds into applying those changes. There is another intermediate step that I'm going to mention later. So in this command, Puppet CA list, we see that it is empty because there are no, this command actually shows the pending certificate requests, and there are none here. And -- shows all the connected machines. Our host name is Revan, pub access host gr, and you see the plus sign before the host name. That means that the certificate is already signed, so it's already trusted, and this machine can apply changes from the master. So let's proceed to the examples now. We are not going to use the master here though. We are going to test our changes faster, and this can be done with the command puppet apply and name of one of those manifests. So this bypasses the master agent communication and just applies those changes to the specific machine directly. Before applying it, let's check the first one. So, this machine is, this manifest is adding a new user. You can see a class named user here, and the name of the user would be test. We also set his UID, the GID, and we also mentioned to Puppet to make the home dir and to manage the home dir for that specific user. As you see on line 3, in order to apply this change, we need to do it with sudo. This does not happen always, but in this specific case, since it has to create the home directory and needs some more permissions, then we need to do it with sudo. Okay. The user, there is no server. There is master and agent. Master and agent. No, the user will be created on the agent. Every operation is being done on the agent. The master just sends the information. So we can run this one. And let's hope that it runs. Yes, it didn't. But we have a clear message here. So the first line says applying configuration version and some number. The second line, though, shows an error. The error is that the group admin does not exist. So we can change it, or we can even remove it. It will take the default one. So now it ran normally, and it notified us that the user is created. Let's go to check it. Yes, there is a home dir there, and there is this new user with the exact UID that we specified, 10,000. Yeah, so the question is that here they are both running in the same laptop, but what happens in a production environment? So in a production environment, you usually have the master that is pretty much isolated from anything. So it's only in your private network, and it sends the information to it just needs to send some information to the agent, do some communication through SSL. And the reason that you want your Puppet master to be extra secured is if someone hacks your Puppet master, then he has access to all your infrastructure. Additionally, in this case, as I said, I'm bypassing the communication between master and agent, and I'm using the Puppet apply command, which is for development purpose, actually. In order to do it normally with communication between master and agent, I need to start the process of the agent, and it will check for new changes every, I don't know, half an hour. It's configurable. Any other questions? Feel free to interrupt me, by the way. Okay. So, second example, that was clear, I think. It created a new user. And in the second example, we see another resource, which is called file, and it creates files. In theory. In practice, it does not create only files, it creates also directories and symlinks. It's good or bad, I don't know, you decide that we have the same resource name, file, for all those data types. Apart from that, I'm mentioning on the top that if you want further help for this resource, you can use the command puppet describe file in order to get more information. Let's run the command first. So, as we see here, it's like a man page. It describes everything about this, this resource and all the extra parameters that we can use, arguments, and also some examples on how we can use this, this type. Earlier, we used the user resource. Let's see the help for the user resource. It also exists, so it also tells us what it is doing, how it is doing it. It does not directly modify the C password or anything. And all the arguments that it supports. So if you don't remember stuff, you don't even have to Google it. You can use all the information from your system directly. Let's go back to the example. So in this example, in the first block, we create a file under TMP called test1. And we also put some content inside the file. It should say hi. The second one, though, is a directory. Although we are using the file provider, it's a directory, and it's, we also set the permissions of the directory to 644. The third one is a symlink, is a symlink. Is a symlink named test3, and it points to test1 that we create earlier. And at the bottom, we put two notify statements. The notify statements are plain print statements that we can use for debugging or for printing some information to our environment. It's pretty common that we get notification mails in a production system about changes that are applied to our nodes. So those notification messages are very good because we also get them in our emails and we know exactly what happened. So the problem here is, though, that we don't specify the order of we don't specify the order that those files should be created. We will see how to specify order in later examples, but there is a possibility here that, for example, test3 will not be able to be created because test1 is not yet created. The problem is that Puppet does not run those statements from top to bottom. It runs them in random order. So let's run this one. And by the way, we don't need any root permissions this time, so I'm switching back to normal user. So, ignoring the first two messages that I have no idea what they are doing there. It's not my laptop, it's his laptop, by the way, so it's his laptop, so blame him for those messages. So here we see that Puppet created those three files that we told it to do, and it also notified us that they are actually created. Then it displayed the notify messages that we wrote. And if you look closer, nothing is in the order that I specified it. The notify messages, for example, are reversed, and the files are created in order 1, 3, 2, while I specified 1, 2, 3. Let's see it again. Yeah, so I specified here this first, then this, but Puppet reversed the order. And the notify messages, it swapped the printing of them. Next example. Any questions so far? Okay. The next example, we see how to specify the ordering that I mentioned earlier in order to solve the problem of broken symlinks. So as I mentioned also here, it could be possible that temp2 might be created before temp1, while it is a symlink to test1. So in order to solve that problem, we add this extra argument, the require one, that says that I want first to call file temp test1 and then proceed into creating this symlink. The structure here is a bit different. As you see, we need to use the capital letter, the first capital letter here, and this column, this brace instead of the carry ones. So I'm not going to run this, it's useless. Let's go to the next example. In the next example, we see a different way to specify ordering, and this time we are using before instead of require. You can see it here. The syntax is the same, but the command is different. And the difference between those two is very thin. I'm not even sure. Actually, in this case, there is no actual difference, but in more complex cases, there is some difference between them. Anyway, I'm going to skip it for now, but you see that there are at least two ways to specify ordering in Puppet. And this is sad because there is also a third way that we are going to see later. So in the next example, we see the third way to specify ordering. And this is more straightforward because this time we are using rows. So we can say that I have those messages, message B, A, D, C, and I want them to be executed in the order A, B, C, D with those arrows, the arrow pointing here. The thing is that we can also do the opposite. We can also use this arrow, and also we can use both arrows here in such a complex scenario. We can use arrows pointing to the same resource as well. It can get pretty complex, though it's not recommended. It can lead to maintenance hell. So we see here that we have those 4 notify messages, and I'm going to run this example in order to make sure that they are actually executed in the order that I want them to be. And as you see, the messages are executed in the exact order that I wanted them to be, A, B, C, D. Any questions so far? Okay. The next example, it's more something that more useful in a production environment. It's about installing packages. So here we see the package resource, and we try to install 3 packages here. Actually, we are not. And the third one is going to be absent, which means that if I find it in my system, then remove it. So the third one is actually removing a package from my system. And as you see, there are different ways to specify the version of the package. There's this special argument called present. Present means that I want the package to be present in my system. I don't care about the version that is currently installed, but I just want it to be here. There is also a similar special argument, latest, which means that I want the package to be installed in my system and also be in the latest supported version that I get from the package manager. Also, we can specify the version explicitly, and we can say it to be absent, so to be completely removed from the system if it is installed, if it is present. Again, we can see this is a pretty complex, actually, resource, the package resource, and again, we can see here the help from the command puppet describe. Anyway, I'm not going to run this command because I'm not even sure if this laptop has those packages, if they exist here. But anyways, it would, and actually it would need also root permissions to run this one example. I'm going to skip this one for later. And here is a more programming-oriented file. It shows that we can also specify a variable here and use this variable as an argument for a file resource. And there is also this special kind of variable. You see the double colon here. And the name is host name of the variable. As you imagine, it prints the host name from the system, but the question is, where does it get that information? So this information comes from a tool that is used heavily from Puppet, and the tool is called Factor. And Factor prints in Ruby style, in Ruby variable style, pretty much everything about our system. It prints, for example, the processor, the operating system, our IPs, disk model, pretty much everything. Domain, host name. So there's a bunch of useful information about our system, and also we can create with like 2-3 lines of Ruby, we can also create our own facts. They are called facts. So we can also create our facts in order to use them for the catalog. So as you imagine, in this command here, it reads the information from Factor and replaces the variable with the actual host name of the machine. This is the extra step that I told you before when the agent and master communication happens. So I told you before that the procedure is that agent asks for a new catalog, master checks if there is actually a new catalog for this specific agent, and sends the information. There is this extra step of Factor here, actually. So agent asks for the information, master sends the information, and agent asks for the information, and master sends the information. Then agent sends the facts, all of the output of the Factor. Then master actually sends the new revision, the new catalog, to the agent, and then the agent applies those changes. So there is this extra step where the agent, the master actually checks all of the parameters of the agent and actually pushes the relevant changes back to the agent. So let's run this one. And it was not printed. Okay. But why? That's interesting. Ah, yes, here it is. Okay, sorry, I'm blind. Yeah, it was before as well. So it's saying that it is running on Revan. Revan is the hostname of this machine. Here's the proof. So it actually replaced the hostname special variable with the fact that it got from the Factor output. Is it understood? Any questions so far? Okay. This is arrival. Yes, yes. No, in this example, it's the same box. Yes. So next one. It's actually more. It's actually a better example of a factor that I presented earlier. In this case, we have host resource. The host resource creates a new entry in etc hosts file. And here we see that we create a new entry where we get the full qualified domain name from factor. We also get the host name from factor and the IP from factor, and Puppet will create a new entry in etc hosts. Another very important thing is this special parameter here, ensure. I showed you ensure earlier in both the package resource and both the file resource. It's a very special attribute for the Puppet resources. It can be used everywhere, even if it's not documented, it still exists, and it's actually the argument that ensures, as its name says, it ensures if this specific item we want it to be present, absent, or present under some specific circumstances. Like in the package, for example, earlier, we specified ensure and the version exactly of the package. So this can be used everywhere, and if it's absent, it means that, so if there is no ensure argument there, it means that the default, it takes the default value, which is usually present. It's still configurable. Yes, I understood. I'm not sure the exact procedure, to be honest. Yes, yeah, I'm not exactly sure about what's the exact procedure, actually. Yes. Yeah, sorry. So, next example. And this is a more real life example. In this example, we have a conditional, first of all. We have an if statement where we check, again from factor, if this box is a virtual machine or not. If it is a virtual machine, then I don't want NTP to be running. If it is a virtual machine, then I want NTP to be installed and running. In this case, we see that we want service NTP to be stopped and enable false. Enable false means that the init script that is running in the system, we don't want it to be enabled. We want to be disabled. We want the package installed otherwise, and we want to ensure that it is running, that it is enabled, that we also mention if it has a restart variable, if the init script has a restart parameter. So Puppet can also do some restarts, apparently. And we also specify an ordering. Here we say that we want first to be installed and then start the service. The else statement gets executed if this variable takes one of false, undef, undefined, empty string, or false like this, like the special false argument. And again, we need root permissions here, both for checking the service and both for installing the package. So let's run this one. So it's stuck for some reason. Anyway, let's... Okay, something was wrong. Anyway, so let's take a break and see this cheat sheet that they are providing in the web page of Puppet. Here there is there are more real-life examples, and the more important one is the one that is called the trifecta, where we specify package, file, and service. This is very common in, it's pretty much in every Puppet manifest that I have seen, and it's very commonly used, it's very widely used. It is what, where we install a package, do some stuff for their config files, and then start the service. It's pretty much everything that we need to know. And in this cheat sheet, there are also a bunch of other resources described, like the cron for cronjobs, the exec for executables, the user group that we saw earlier, package, file, and service. If we have any time later, we're probably going to see some examples from here as well. So, next example. And this is a more complex example. In this one, we cover the case where we run a bunch of servers and different operating systems in all of them. So in this case, we have this case statement, and we check the operating system of the box. And depending on the operating system, we define the Apache variable, and then we install that variable, we install that package in reality. So as you see, Puppet supports a bunch of operating systems here, a bunch of Linux distributions, and it also supports Windows and Mac OS X. So you can, with the same Puppet manifest, you can cover a wide range of operating systems, a wide range of servers. And that's one of the most powerful things that it has, actually. And I'm going to skip that one. Let's go. And one more thing. We see here this default statement. This one means that if this case command does not find any of those operating systems, then it goes to the default one. So it's like the backup one. And here we define this fail function where we just print a message to the user. So it prints that those red errors that we saw earlier. Actually, let's run it. I'm curious what will happen. Unrecognized operating system. So this operating system is unrecognized because it is it's not supported, yes. Next example. That's all. So which one I skipped? Yes, so I skipped this one earlier. Let's see this one for a minute. In this one, we include SSH. What does it mean? We include something. Is it a library? Is it a header? Actually, it's a module. It's, as I said earlier, in Puppet, we group our code into modules. And here we just load this module. And this module is present in the modules directory. In your infrastructure. Usually those files are going under etc Puppet manifests, where there are the top level manifests, and etc Puppet modules, everything else. Like you can also put there the third-party modules that you get from the forge. So here we have this SSH module, and it has this structure, it has 3 directories called files, manifests, and templates. Let's see the manifests first. Manifest has the init.pp file. It's like the main file for Puppet. And here it defines a class where it installs the openSSH server, but before applying the config file, then it applies the config file, it defines variable SSH ports, and this is a list actually, it's not a string. Another SSH config file, the SSHD config file this time, where it uses a template. We'll see the template later, and then it starts the service. Two things here. First is this argument, the source argument. It points to Puppet, semicolon, 3 dashes, modules, SSH config. This is the so-called file server of Puppet, where we put the static files. So this SSH config file is a static file that we just copied from this path to our system to etc ssh config. And this is in this directory. It's exactly this file, so it's copied from some default config file for some distribution probably. And it will be copied as it is to our system, to the defined path, to this path. And the other one is using a template. So in the template, as I said earlier, we can put some conditionals, and we have a template here in Ruby style format, in ERB. It's called SSH config ERB. Let's see it. Templates, SSH config. So here we put some Ruby, and we say that for read the SSHD ports list that we defined earlier, and for each one of them add an entry port. So in our hosts it will be this one. Then we define some other, anything else interesting here? No, everything else is hard-coded. But still, you know, we can put some Ruby here, and we can define many of those options, so we can make all of those hard-coded configuration here and make it very configurable for our various servers. And it's very handy, maybe it's not for SSH, but for example, for Apache configuration, it's very handy to have such configurability between your servers. So this is pretty much all about my examples. I could use some time to show you the Puppet forge that I mentioned earlier. This is the web page that has various Puppet modules that you can download and use already. And you can also upload yours as well. You can also share your work to others if you feel that it's reusable enough, or it's worth it because it has some cool ideas there. So let's see one. One of my favorites is this one. Anyway, another one. So let's, for example, search for an Apache module, and we see a bunch here from various people. This one is provided by Puppet Labs themselves. And there is also another command, Puppet module install, where we can install modules from the forge directory. So if we don't want to use Git to clone it, or if we don't want to use our distribution package manager, we also have the option to use this command in order to install modules from the forge directory. And here it presents some information like a README file, changelog, dependencies to other modules, very handy. So this Puppet module command handles also the dependencies. Some custom classes, some custom types, and the license and openSUSE. Most of the modules are in GitHub, so it uses the GitHub API in order to get all that information. And this is the GitHub URL, for example, for this module. So we see here the code, and we can also contribute to those people if we think that something is missing or whatever. And this is another one that is one of my favorites, and it's pretty weird because it's a Puppet module that administers Puppet itself. So with this module, you can set up your Puppet master and your Puppet agents. So it's like Inception. And last one is this module. It's very interesting. It's openSUSE specific, where you can administer the repositories for an openSUSE installation. And here is the usage. It's pretty straightforward. And actually, there's another guy, there's Microsoft in SUSE that is working on providing some extra functionality for the zypper backend for Puppet in order to be able to define additional arguments in order to be able to have a repository. Yeah, that's the case, like to handle repositories with Puppet itself without needing this module even. And I think that's pretty much all. Okay, so the question is, what software would we have to install it in order to set it up, correct?
Yes, in our company, we have a monitoring system where we have to install a client on every server and make sure they come with Puppet on it.
Okay, so you can... Yes, sure. So, the question is what we need to do in order to install it and provide some production example and some real environment. So I'm actually working on a sysadmin team, both in my company and in my free time, and we are using Puppet in order to administer our servers. We try to not touch the machines, not even have shell access to the machines and do everything in Puppet, write all our modules, all our code, all of our logic into Puppet and distribute it to the machines. We can, one good thing is that Puppet has classes of the nodes. So when you define a node, you can say in Puppet directly that I want this one to be a database machine. This one I want it to be a web node. So if you automate it a bit more, you can even just define this one and Puppet will do the rest and set up a web node there without you touching anything. So, if I understand the question is, where does it get the software packages in order to install them? So, good question. It uses, I forgot to mention it earlier. It uses the package manager of your distribution. So, the Puppet Lab guys wrote an abstraction layer between Puppet and the package manager. So, that's why it supports all those operating systems and all those Linux distributions, because people have actually wrote some code in order to read some information or some API calls from the package managers and present it to Puppet into some Ruby data that Puppet can parse and do some operations based on that information. So it uses natively your distribution. You don't have to do any other dirty hacks there. And in best case scenario, which will never happen, you won't even need to write any ugly hacks in order to administer your infrastructure. And about the second part, about monitoring, for example, that you mentioned, I mentioned earlier the Puppet dashboard, which is kind of like a monitoring system for Puppet. Unfortunately, I don't have anything set up now to show you, but anyway. There is this web page that prints the nodes based on the classes of the nodes, their uptime, the changes that they did recently. But for sure, you can also put some nagios checks on top of that in order to check if your machines are operating. So you can connect those two and make them report to each other, for example. And there are a bunch of pretty good nagios Puppet modules on the internet as well that you can use. So pretty much in a production environment, actually I'm going to extend more about the production environment in my presentation on Sunday. But in short, what you need to do is to apply an hierarchy in order to use some modules from the forge, and on top of that to write some extra code that should be specific to your infrastructure. Because most of the modules that are in the forge are reusable, so they are pretty generic. So you need something in order to apply some configuration to your infrastructure based on that. Question? Anything else? I didn't. Sorry. Yes, so the files were created in TMP. In the first example, if you remember, I created a plain file. It is created, test1. Then I created a symlink to that file, test3, a symlink to test1. And then I also created the directory. Here's the directory. So everything was created, but I forgot to show you, sorry. Sorry about that. Bitcoin. Okay, so repeating the question for the recording, the question is, according to the documentation, we need for sure 2 machines in order to set up Puppet. We need a master and an agent, but here in my example, I'm setting up both in one machine. Yes, so for sure you can do both in one machine, and actually your master is also an agent. It also performs as an agent. It also needs some information from your system, you know, in order to operate. So, so the question is if I can set up some virtual machines here and do some further testing. Yes, I can also do that, and Puppet Labs recently developed a very nice tool that creates virtual machines and administers virtual machines in order to set up specific Puppet test environments, so you can check your code before pushing it to production. And it's one of the tools that I also am going to show on Sunday in my presentation. It will be recorded. Anything else? Nothing else? Okay. So, that's pretty much the very basic stuff of Puppet, but as you saw, it's very powerful because we can apply conditionals, we can have the variables. There's plenty of code on the internet. It's centralized, fortunately. So even in your machines, in your laptops, for example, you can do such. You can write some simple manifests in order to automate some stuff. In order, you know, if you want to reinstall your system, you don't have to go back from the beginning and configure some stuff that would be configured either way. Yeah, so that's pretty much the very basics of Puppet, but still you can experiment. It's a very powerful tool. I highly recommend it. And in case you want to talk about it with me further, I will be around. Feel free to talk to me, or also to the internet. And I think that's all. Thank you very much.